Hi, and welcome to week 7. Can you believe it? It's almost midterm time. Next week, midterms. Hope you're studying. All right, so this week we're going to talk about properties and order of operations. So hopefully you're building community with your teammates through our activities. Don't forget about the FAQ discussion board. You can always post on there. If you're stuck on a problem or an assignment or just have a question, you can post right there. We're also going to talk about properties of whole number operations as well as order of operations. We'll still be practicing our math practices, MP2, MP4, 6, and 7. So quick warm up. Do you remember how to use a non-traditional division strategy? You could use base 10 blocks. I wouldn't advise it here necessarily. Or you could use the partial quotients. So I prefer partial quotients. Pause the video right here and then take a check and make sure it makes sense. All right, how'd you do? Here's how I did it. I did partial quotients. I did not show my check with multiplication. How you would do the check is you would do 9 times 147 plus 6, and that should give you 1,329. Hope you're liking that new division strategy. All right, here's another flashback warm-up. These are all practice things for your midterm. So what are the parts of the math sentence or the number sentence? Make sure you spell correctly. So you have an addition sentence, a subtraction sentence, a multiplication sentence, and a division sentence. So pause the video here, try to do those, and then check your answers. Did you get them right? Did you know addend, sum? And did you spell them correctly? Then remember minuend, subtrahend, difference, factor, product. Now, just so you know, some people say multiplicand and multiplier. That just gets really confusing for students, so I stick with factor, product. And then dividend, divisor, and quotient. Those are the ones that you might miss up spelling, so practice those before the midterm. So let's think this through. So properties of addition, we might have discussed briefly commutative and associative properties of addition way back a few weeks ago when we did addition. So think about whether those properties would apply to subtraction, multiplication, and division. What are they, and how and why do they apply to addition? And we're going to talk about these throughout this week's lesson. And think about each one of each one of the operations, including subtraction, multiplication, and division, and why the associative and commutative do or do not apply. So here's some properties of addition and multiplication that we're going to talk about: the associative property, the commutative property, the identity property, and the distributive property. Again, spelling is really important since you're going to be the teacher, so you need to make sure you practice spelling those words. The one that I see misspelled most often is commutative. So it's kind of like commute. Okay, there's no N in there. Okay, so let's look at some problems. So notice I put that little icon in the top right where it says addend, sum. So let's try a couple of these. Sheldon has $5 and earned $7 more organizing a closet. How much does he have altogether? Take a second and write down the number sentence that you would model for that problem. You can even think of the things we learned a few weeks ago, like, is it a join problem? How do you know all of these things? Which part is missing? Okay. Then the second problem, Leonard had $7 and earned $5 more solving math problems. How much does he have altogether? So notice that that problem is different than the first problem. It's a different context. It uses the same number, but something has changed. So write down your number sentence for that. We'll check those number sentences in a second. So what I want you to think about is when you add two numbers and reverse the order of the addends, what are the sums? So in the first problem, you wrote $5 plus $7 equals $12. In the second problem, you wrote $7 plus $5 equals $12. So there's still a 7 and a 5, but this time the addends are reversed. So when you add two numbers and reverse the order of the addends, the sums are equal or the same. That is the commutative property. So 2 plus 3 equals 3 plus 2. Changing the order does not change the result. That's true for addition. Okay, now let's look at a subtraction problem. So we have minuend, subtrahend difference. The temperature in Minnesota was 8 degrees Fahrenheit. It dropped 5 degrees Fahrenheit after sunset. What was the temperature after sunset? Model that number sentence. Now part B, the temperature in Alaska was 5 degrees Fahrenheit. It dropped 8 degrees Fahrenheit after sunset. What was the temperature after sunset? So you can see how those sentences or those number sentences might be related, but they're different. So we're going to look at what those are. So make sure you have your number sentences written down. So here's the number sentences I wrote down. 8 degrees Fahrenheit minus 5 degrees Fahrenheit equals 3 degrees Fahrenheit for part A. And for part B, 5 degrees Fahrenheit minus 8 degrees Fahrenheit equals negative 3 degrees Fahrenheit. So that's an interesting thing because we changed the order of the numbers. This time they're not called addends because we're in subtraction. They're called the minuend and subtrahend. And we should have noticed that the differences are not equal anymore. They're actually opposites of each other, or what we would call additive inverses. All right, so our results that we figured out when we looked at those examples are when you add two numbers and reverse the order, the sums are equal. But when you subtract two numbers and you reverse the order, the differences are opposites. That is that there is a commutative property of addition, so you can reverse the order of the addends in an addition problem and it doesn't change the sum. And specifically, if we were talking in general, we would say A plus B equals B plus A. Subtraction, on the other hand, is not commutative. We cannot reverse the order of the numbers in a subtraction sentence and get the correct answer. And then notice where it says, in fact, A minus B is actually equal to A plus negative B, or the opposite of B. And we're going to use this when we do integers, and you've used it in the past when you solve integer subtraction problems. A lot of you were taught to rewrite them as addition. So the commutative property of addition, we're just going to go over it again. Here's an example that you might see in a young elementary school classroom. Suppose you start with 1 apple and then get 3 more. But what if you started with 3 apples and then you get 1 more? Common sense tells you that you would have the same number of apples. Sometimes teachers call these turnarounds with children, and it's a really easy idea for them to understand. But very shortly after, you're going to refer to a turnaround as the commutative property, so they start using that vocabulary. Let's look at this problem. So now notice we have factors and a product. So Penny made 3 batches of cookies with 6 cookies per batch. How many cookies did she make in total? So write your number sentence there. And then part B, Amy made 6 batches of cupcakes with 3 cupcakes per batch. How many cupcakes did she bake in total? If you're thinking back to multiplication from a couple weeks ago, these pictures would not be the same, right? So in part A, we would have 3 groups or 3 copies of 6 cookies in each one. In part B, we would have 6 groups with 3 cupcakes in each one. So they're different number pictures in your mind, and they're different number sentences. Here's our number sentences. In part A, 3 batches times 6 cookies per batch would be 18 cookies. And in part B, 6 batches times 3 cupcakes per batch would be 18 cupcakes. So you get 18 either way, whether you do 3 times 6 or 6 times 3. So what we noticed was when we multiply two numbers and reverse the order of the factors, the products are still equal. What happens when we do division? Remember the dividend, divisor, and quotient, and the parts of them, no matter how they're written. Notice this second part down here is written with a long division symbol, so make sure you can still identify the dividend, the divisor, and the quotient. So part A says 2 people are sharing 4 pizzas. How much pizza does each person get? Think about that number sentence and write it down. In part B, 4 people are sharing 2 pizzas. How much does each person get? Write that number sentence down and compare those. Did you get 4 pizzas divided by 2 people is 2 pizzas per person? I hope they're hungry. 4 people are sharing 2 pizzas for part B. This time it's 2 pizzas divided by 4 people, so this time they only get a half a pizza per person. What's funny is probably half a pizza is plenty. So the results I want you to focus on is when you divide 2 numbers and reverse the order of the dividend and the divisor, the quotients are not equal. They're actually reciprocals or multiplicative inverses of each other. So the commutative property of multiplication is when you can multiply the factors in any order and you'll always get the same product. Here's it restated another way, and it's important that you compare this generic statement of A times B equals B times A, and division is not commutative. A divided by B is not the same as B divided by A. Now, if you start focusing way back in the very beginning with what the parts of the number sentences are equal to, it might help you remember if there's a commutative or an associative property or not. So notice that in an addition sentence, both the numbers are called the same thing, addend. So order wouldn't matter. I can exchange those and it won't change the outcome. Same with multiplication, factor, factor, product. So that's nice. Those are interchangeable. But notice in subtraction, those two things are called different names. One's called the minuend and one's called the subtrahend. That should give you a clue that you cannot change the order. The same is true for division. We have the dividend and the divisor, so you can't change the order of those. If they were called the same thing, we could maybe guess that you could, but they're not, so you definitely can't. So there's no commutative property for subtraction or division. It's a good connection to what we learned before. Remember, multiplication is just repeated addition, so they should have the same properties in regards to order. Then division and subtraction, remember division was repeated subtraction. So if there was no commutative property for subtraction, there's no commutative property for division. I hope you're connecting all 4 of these. All right, properties of 0. So we have an addition property of 0. Sometimes that's called the identity property. So adding 0 to a number does not change it. The multiplicative property of 0 or multiplication property of 0, when you multiply 0 times any number, you're going to get 0 as the result. If 0 is a numerator, we learned this last week, then our answer is 0 as long as the denominator is not 0. And we don't do division by 0. Okay? And the reason, you should really think about that, the reason you can't do division by 0 is because there is no number that you can multiply 0 by and get a number like 5. So I couldn't replace this undefined with a number and get 5 as my answer. No number exists like that. All right, the identity property of multiplication. Sometimes it's called the multiplicative identity property. Sometimes it's called the identity property of multiplication. So a number times 1 is still that same number back, or if you reverse that order, 1 times a number is still the number. Let's look over these. It says complete the following table by performing the indicated operations by computing the result using order of operations. So make sure you work through all of these. Work through parentheses first on both problems and then compare problem 1 and problem 2. Are the results the same for each addition, subtraction, multiplication, and division? So I hope you got 15 for the addition problems, both of them. So yes, those results are the same. For the subtraction problem, the results are not the same if you do parentheses first. On multiplication, they are the same. And then for division, they are not the same. So notice it was just the parentheses that we were following this time. So addition and multiplication both have the associative property. That means that we can change groupings. So notice the order didn't change. Notice that it still goes A, B, C from left to right on both sides of the equation. But what has changed is where the parentheses are, or the grouping symbols. So in the first one on the left, it says A and B are grouped together, and then you add C. On the right side of the equation, it says B and C are grouped together. So you do A plus the answer from B and C. And in multiplication, same thing. It's the parentheses or the grouping symbols that moved. Okay? So this is not the case in general for subtraction and division. So if you have a problem where the operations are either all addition or all multiplication, you can do it in any order you want. And we do that a lot, right? Regardless of the parentheses. Sometimes we have a whole list of numbers and we add them up in different groupings that we want. This was also what you were doing with your addition strategies. Do you remember decomposing and recomposing by place value or by friendly numbers? It was the associative property that was allowing us to do that. Okay? And you can remove parentheses altogether if you want to, if there's all multiplication or all addition. So that's the associative property for addition and multiplication. Here's a classroom example. Suppose there are 3 groups of marbles, one with 4 marbles, one with 3 marbles, and one with 2 marbles. If we put the first and the second groups in a bag together, we still have the same total number of marbles. So notice down here, if we group the yellow and the red together, the white and the red together, we get the same answer of the total number of marbles as if we group the blue and the white together. Okay? So now let's look at a application problem. Linda has a rectangular flower bed that's 10 feet long and 4 feet wide. She's going to plant morning glories and tulips. She wants more morning glories than tulips. And so she's dividing the garden shown in that picture. So this is what you should do. Part A, determine the total area of the garden by multiplying its total length times its total width. So write that number sentence and calculate the answer. Part B, determine the total number of square feet that will be planted with tulips. So show what quantities you multiplied. So write that number sentence. Part C, determine the total number of square feet that will be planted with morning glories and see what quantities you multiply. And lastly, determine the total area of the garden by adding the area planted with tulips and the area planted with morning glories. So take a minute to do that. Here's our answers on the next slide. So 10 feet times 4 feet is 40 square feet. That's the total square footage of our garden. The total square footage of tulips is 3 feet times 12 feet, 3 feet times 4 feet, which is 12 square feet. The total number of square feet that's morning glories is 7 feet times 4 feet, which is 28 square feet. Now, you could do this 2 different ways. You could determine the total area of the garden by adding the area planted with tulips and the area planted with morning glories. So notice you could do 12 feet squared plus 28 square feet. Or you could look at it like the distributive property, where you're adding the 3 feet and the 7 feet together and multiplying it by 4 feet. Or you can think of 3 feet times 4 feet plus 7 feet times 4 feet, and you'll still get 40 square feet no matter which way you do it. So we do have a distributive property as well. Here's a challenge. Can you simplify that expression? And then the key to it is justify your steps. Can you say why you're able to do the things you're able to do using the properties that we were just discussing? All right, take a look. So first we had the given statement. From the first line to the second line, we just reordered things, and we're allowed to do that with the commutative property. Now, be sure you understand that there is no commutative property for addition, but if we're really doing adding the opposite, so instead of minus y, we're really saying plus negative y, then we're able to rearrange these. The associative property. So now I'm grouping by like terms. So I'm able to group things using the associative property. Then I'm just going to simplify. Then what I'm really doing on the next step is the distributive property. You might not have thought about that before when you were doing algebra, but that's the property that actually enables you to do that. And then we're going to simplify again, and then we can just rearrange. Notice it was x times 4, and we wrote it as 4 times x, or 4x, and we're allowed to do that because of the commutative property. So the reason we're able to do all those complicated algebra problems that you've done before is based on these very simple number properties that students learn in elementary school. You have some properties assignments on Canvas. You're going to make your own foldable to show the properties, and you're going to give an example of each. I have an example of mine up, but this is your chance to be creative. It can be whatever you want. The second 2 assignments you have on Canvas are there's some games with addition and multiplication properties, and you're going to screenshot your results. You're also going to write a paragraph because it discusses what standards you're meeting. So those should be fun. I think one is soccer and one is basketball. So you could pause the video here and try those assignments, or you could continue through the rest of the video. All right, so order of operations. Remember order of operations from 5th grade? And I don't know about you, but I always see those questions on Facebook and they make me laugh because people discuss, oh, new math is crazy or whatever. So those are fun to look at. So order of operations. Let's just take a look at some things. So you have $12 in your wallet. You spend $8 in lunch, and then your friend pays you back $3 they owed you later that day. So write a mathematical expression that shows that, just one singular mathematical expression. So you have $12, you spent $8, then your friend pays you $3 back. Then simplify the mathematical expression and interpret the answer based on the context. All right, so if you wrote your expression, you might have done it one of 2 different ways. So if you wrote your expression 12 minus 8 plus 3, we could do it the way if we do the left from a left to right, or we could do it where we start with the right hand side first. So try it both ways and see if you get the same answer. You do not. If you went from left to right, you did 12 minus 8 and got 4, and then you added 3 for a result of 7. If you did the right-hand side first, if you did the 8 plus 3 first, you got 11. And then you did 12 minus 11, and you ended up with 1. So the rule is when you need to add or subtract 2 or more times in one problem, perform it the same way you read, from left to right. Here's another one. Jim needs to bake a lot of cookies for the bake sale at his school. Jim makes a batch of 120 cookies and boxes the cookies. Each box can hold 10 cookies. How many boxes will Jim need for 1 batch of cookies? And then how many boxes will Jim need for 3 batches of cookies? So think about these expressions and see what you will write. All right, so if you wrote one singular horizontal expression for this scenario where he needs 3 batches of the cookies and how many boxes does he need, you would have the expression 120 divided by 10 times 3. So we could do the left side first or the division first, or we could do the multiplication first. We have to decide which makes more sense in this situation. So will we get the same answer? Try those and see. All right, so if you do the 120 divided by 10 first, you're going to get 12 times 3, and you're going to get 36. Is it true he needs 36 boxes? What if we do the right-hand side first? What if we do 120 divided by 10 and get, on the right-hand side, what if we do the 10 times 3 first and get 30, and then do 120 divided by 30, we get 40. So which is right? What do we need? Do we need 36 boxes or do we need 40 boxes? Think about it. So the rule is when we need to multiply or divide 2 or more things in one problem, we're going to go just the same as we did with addition and subtraction, from left to right. Here's another example. So Nathan went to the store and buys 2 cans of energy drinks and 6 packs of and 3 6-pack cans of diet soda. How many cans did he buy in total? So create a mathematical expression that models this directly, and then simplify the mathematical expression and interpret the answer to the question. So if we wrote our expression exactly like it is, he bought 2 cans of energy drinks, so we wrote that first, and so we're going to add 3 6-packs of cans of diet soda, so 3 times 6. So which do we do first? We could do the addition first, or we could do the multiplication first. Let's see if we get the same answer. We do not. If we do the addition first, we get 2 plus 3, which is 5, and then we do 5 times 6, and we get 30. So is it true that he bought 30 cans? Or should we look at the multiplication first, where we did the 3 times 6 and got 18, and then we added 2 plus 18 and got 20. So how many cans did he buy? I think when you look at this scenario, you'll see that we actually should do the multiplication first. So our rule for our order of operations is that we're going to do the multiplication and division before the addition and subtraction. Sometimes you also run into exponential expressions in an order of operations problem. This is just a flashback reminder of what it means. So 2 times 2 times 2 times 2 times 2 is the same as 2 to the 5th. And our rule with order of operations is we're going to do our exponents, which would include powers and roots, before we're going to go on to multiplication or division. Grouping symbols. We use grouping symbols in a mathematical expression to show which part of the expression should be done first. The grouping symbols you most commonly see in mathematical problems are parentheses, brackets, braces, but you also have symbols that imply grouping, like absolute value bars and the radical sign, and the division bar between the numerator and the denominator of a fraction. So make sure you perform all your grouping symbols first. So you have several or a couple activities on Canvas this week besides your more assignments. One is making a foldable by watching a video on order of operations, and you can follow those directions. And the other is a game on order of operations that I think you'll enjoy. It'll give you great practice, and you'll get all those weird questions on social media right. So you have other assignments on there. You have a couple more assignments this week. You have a quiz as always. Make sure you get all your assignments done on time and you start practicing for the midterm. Don't forget about your classmates. You could form a study group and even meet online if you want. So we did it. We made it. Week 7, you finished the video. Make sure you do those Canvas assignments and let me know if you need anything. All right, so this is if he needs, it's the second part, right?